Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 05 of a unit current electricity. So let's begin with today's class. In today's class we are going to discuss about the combinations of the resistors. In previous class we have been gone through the temperature dependence on resistance and resistivity and certain other topics just like an temperature coefficient and the color coding. Today we are going to discuss about the combinations of the resistors. Yes, I hope you have already studied this in class 10 as well, so you might be aware with the derivation and that kind of stuff. So we will just quickly revise it and move to the numericals. So let's begin. How many types of combinations of resistors is possible? We know that two combinations can be possible. One of them would be the series, another would be the parallel. Even we have done this with capacitors as well, so you might have an idea from the capacitor as well. Let's look at the figure. We have three resistors, R1, R2 and R3, and these three resistors have been connected in series with a supply. The supply is given as a V, and let's suppose the current is moving in this direction. We always say the current is moving from positive terminal of the battery to the negative terminal of the battery, and I assume that total current that is flowing, that would be an I. Now what happens that if let a battery of voltage V is connected across the series combination, and the current I will pass through the each of them, that we know that as they are connected in series, the current I will be common to each resistor. So let us suppose that RS is the equivalent resistance of the series combination, and V1 and V2 and V3 are the value of potential difference across R1, R2 and R3 respectively. If you want to look at the diagram, it would look something like this. It's an R1, R2 and R3, and we have connected this with a supply of V, and let us suppose what we understood is that voltage or potential difference across resistance R1 is V1, potential difference across resistance R2 is V2, and potential difference across the resistance R3 is the V3. So this is equals to V is equals to, we can understood that it is a V1 plus V2 plus V3. One more thing, let us suppose total current that is flowing, that is of I. So what I can say, I into RS. This RS is the equivalent resistance. This is equivalent resistance. Yes, this is I into RS. That would be equals to IR1 plus IR2 plus IR3. If I cancel this I, then RS would be equals to R1 plus R2 plus R3. I hope those things are clear. Yes, if you remember the case of the capacitors, this is the, that means CS is equals to C1 plus C2 plus C3. This kind of relation was there when the capacitors are connected in parallel. Here resistance are connected in series, and I got this kind of relation, that is RS is equals to R1 plus R2 plus R3. Now let's look at some of the concluding points regarding the combination of the resistors when they are connected in series. That when we connect resistance in a series combination, same current flows in all resistors. This is compulsion. That means I1 equals to I2 equals to I3. That means the total current I and that current would be equal. The total potential difference of the circuit would be equals to the summation of all the potential difference across each individual resistance. I can say V total is equals to V1 plus V2 plus V3. One very important topic and one very important conclusion is, as I is same through each resistor, that means V is equals to IR, and that means voltage is directly proportional to the resistance, as I through each resistance is equal. So what I can understand and what I can conclude is voltage is directly proportional to the R. That means if resistance increases, voltage increases, and if resistance decreases, voltage also decreases. Is it clear? Is it? Great. Next, when two resistance, let's say R1 and R2 are connected in series. Suppose the situation is something like this, that current I is flowing, and as these two are connected in series, potential drop across the first is the V1 and potential drop across the second is V2. So what I understand, that is the V is equals to V1 plus V2, and according to this I know that R equivalent, this is the R equivalent, should be equals to R1 plus R2. Now if I want to calculate this V1, what it would be, so I can write like this: V1 is equals to I into R1. Now what is I? So if I put up a value, it's I is equals to V divided by R1 plus R2, because current through every resistance would be the same. So this is equals to V divided by R1 plus R2 multiplied by R1, or you can say it's an voltage across or potential difference across any resistance can be written as our own resistance divided by total resistance multiplied by V total. Please remember, this is known as the voltage divider rule. This is voltage divider rule. What is this? If I want to calculate the V1, it's a potential difference across the first resistance, then V1 should be is equals to my own resistance divided by R total multiplied by V total. A same way V2, V2, it's a potential difference across second resistance, it's our own resistance, which is an R2 divided by R total multiplied by V total. So this is the voltage divider rule. Please do remember this. This will make our calculation much faster. Next, always effective resistance will increases. That means R equivalent will be always greater than any of the individual resistance, always. And one more, effective resistance is greater than the largest resistance in the combination. Yes, I hope these points are clear to you. Yes, so shall we switch to the resistance in parallel? Yes, first we are going to see this two combinations, and then we will switch to the questions and numericals based on this only. So let's look at this. Three resistance are there, R1, R2 and R3, and they are connected in parallel. Now first and very logical thing is how one should know that my resistors are connected in parallel or series. How can you identify that this resistors are in parallel or this resistance are in series? Because as an examiner, I am not going to tell you that this are connected in series and apply this relations, or this are connected in parallel and apply that relations. So what you need to consider is that when current is having more than one option, then it will be parallel combination. Always remember this thing. Yes, and when current does not have any alternate path, that means it is compulsion for current to pass through that path. That compulsion will show that resistors are connected in series. I hope these things are clear to you. Is it? Now let's look at this. This is the current I that is flowing through this three branch. This is the I1, this is the I2, and this is the R3. And the current is passing through, that I1 current is passing through resistance R1, I2 is passing through R2, and I3 is passing through R3. So let's calculate the parallel resistance or parallel equivalent resistance of this combination. Let's have a look. If a battery of voltage V is connected across the parallel combinations, and the potential difference across each resistance will be equals to voltage of battery, that is V, and suppose the current are passing, that is the I1 is passing through R1, R2 is passing through R2, and I3 is passing through R3. Then the current in the main circuit, the situation was something like this. It was the R1, this was the resistance R2, and this is the resistance R3, and this connection has been connected like this with a supply voltage of V, and we knew that current I1 was passing through this, I2 is passing through this, and I3 is passing through this. Then I total current I would be equals to total current I would be passing through here, and from this point it is going to divide it into respective branches, so that I can write like this. It's an I is equals to I1 plus I2 plus I3, and we know that in a parallel connection voltential difference across each resistance will remain the same. So what I can write? I can write I is equals to V divided by Rp. Rp is the equivalent resistance, equals to I1 is equals to V1 by R1, I2 equals to V by R2, and I3 is equals to V by R3. Now let's replace the value of I1, I2 and I3. So I could be written as V by Rp, I1 V by R1, I2 V by R2 and I3 V by R3. So this voltage has gone, and whatever the remain, it's in 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Yes, this is the R equivalent when resistors are connected in parallel. When capacitors are connected in parallel, so C equivalent for parallel combination was C1 plus C2 plus C3 and onwards, and C equivalent when they are connected in series was 1 by C1 plus 1 by C2 plus 1 by C3. Yes, we can remember that they are just reciprocal kind of things. Yes, uh, equivalent capacitance when they are connected in parallel looks like the when resistors are connected in series, and vice versa of the same. Remember this. Okay, let's get back to the resistance. Suppose these are the certain conclusions that what would be the situation when and when we connect any resistance in parallel combination, my total voltage will be equal to the each individual voltage, because I know that voltage remains the same. Voltage remains the same when resistors are connected in parallel. Total current will be equals to an addition of all these currents that has passed through different and their respective branches. As I know voltage remains the same, and I know that I is equals to V by R, voltage is going to remain the same. So I1 is to I2 is to I3 can be written as 1 by R1 is to 1 by R2 is to 1 by R3. Now very important, it's in current divider rule. What amount of current will be passed through first branch, what amount of current will be passed through second branch. How could I calculate? So let's have a look. I know that total current I will be the addition of I1 plus I2. Yes, even I know that I is equals to total current I should be is equals to V divided by Rp. It's a V divided by R equivalent. Now what is R equivalent? My R equivalent, this is equals to V divided by 1 by R1 plus 1 by R2. If I solve this, it's a V divided by R2 plus R1 multiplied by R1 R2. This is the total current. So if I write this, it's a V multiplied by R1 R2 divided by R1 plus R2. That should be is equals to let's suppose I want to find out the value of an I1 plus I2. It is the V divided by R2. So if I write it's an I1, that should be is equals to V multiplied by R1 R2 divide by R1 plus R2 minus of 1 by R2. If I'm going to solve this, what I can have is that This is equals to total current I divide by R2 divide by R1 plus R2. I hope these things are clear. Is it? So when I write the current that has been passed through first branch, what I should need to write, it's in total current I multiplied by current through or resistance of opposite branch. It's R2 divided by R1 plus R2. And while I am supposed to write an I2, I should write it's a total current I multiplied by resistance of opposite branch, which is R1, that divide by R1 plus R2. I hope those things are clear. Is it? Is it? Yes, great. Let's have a look at some more conclusion. But this or conclusion are very effective, and this or conclusions are very important to calculate the questions in a rapid manner. Let's have a look. That effective resistance is always less than the least in the combination. And for an identical condition, this is very important, for an identical conditions, the equivalent resistance would be equals to R divided by N, where N is the number of resistors. N is the number of resistors. I hope those things are clear. Now let's suppose one more thing. If N wires each of resistance R are connected to form a closed polygon, equivalent resistance across any two adjacent corner is R effective is equals to R multiplied by N minus 1 by N. A thing is something like this. Let's suppose a square is there, and each one is each side is having a same resistance. And suppose this four wires has made this square, and each one is having a resistance R. And suppose you have been asked to calculate the RAB, something like this, then you can use this. Is it clear? Is it? Great. Next, for n identical conditions, let's say RS and RP be the effective resistance in series and parallel combination, then the ratio of them, I know that RS, when all resistance are identical, look at this, RS should be is equals to N into R. RP is equals to R divided by N. If I take a ratio of this, it is RS by RP, this is N square is to 1. Is it clear? Is it? Now let's look at the special case last. Let's have a look. We have a cuboid, and the cuboid having a dimensions of L, B, H. Now let's suppose I want to calculate the resistance across AB. I want to find out the RAB, what it would be. So when I consider RAB, what I need to consider is that let's suppose a supply or a battery has been connected from here, and you need to find out the resistance. Now what is the standard, or what we can say, what is the basic formula of resistance? I can say it's an R is equals to rho multiplied by length through which electron should travel divided by cross sectional area of that side. So when I consider from A to B, the length that has to be traveled is L. So I have written here rho into L divided by their area. Look at this plate, cross sectional area of this plate, B is its height and H would be its width. It's B cross H. Is it clear? Is it? Great. Now let's suppose I need to find out resistance across CD, RCD. What the situation would be? Situation could be look like this. Yes, that means electrons must travel from C to D at this position. So what would be the situation? Its length would be the B, and its cross sectional area would be equals to this, it's L cross H. And resistance across EF, resistance across E to the F, it's a diagonal, that REF is equals to rho into H divided by L into B. Now what is the maximum resistance? Maximum resistance would be equals to rho into L divided by B cross H, and minimum resistance, minimum would be equals to REF, which is equals to rho into H divided by L cross P. Is it clear? Is it? Any doubts? Any doubts? No? So shall we move to the practice questions? Let's have a look some of the MCQs and then practice questions. Suppose a wire of resistance 4R is bent in the form of a circle. What is the effective resistance between the ends of a diameter? Okay, so let's have a look. This is the wire and that has been converted to a circle, and this wire is having a resistance, that means R total was having a resistance of 4R. What is the effective resistance between the ends of the diameter? Let's suppose I have picked this one point and I choose diameter, that's why I picked this is the second point. This is the center point. So as I know that this, if I consider this A and B, then the resistance of this wire is 2R and resistance of this wire is 2R, because it has been divided into two parts. And when it has been divided into two parts, 2R and 2R, my R equivalent can be calculated as 1 by R equivalent is equals to 1 by R1 plus 1 by R2. That I have calculated. 1 by R effective is equals to 1 by 2R plus 1 by 2R. While I calculate this, it's a 2 by 2R, and when I calculate this, it's a 1 by R, but that is 1 by R effective. What I require R effective, so that R effective could be written as an R. Yes. What was your answer? Is it same? Great. One more thing. When two resistance are equal, look at this here, both the resistors are having a value of 2R only, then I can write it's an R equivalent would be equals to R divided by N. This is 2R divided by 2. It's an R. This is the faster approach. You must go with this. I hope this is clear. Is it? Great. Next. The equivalent resistance of a resistance in parallel. When we connect resistance in parallel, equivalent resistance of resistor will be always lesser than the least of the component. And if it is a case of a series combination, then the equivalent resistance of resistors will be always greater than the biggest component of the resistors. Please remember this. Please remember this. Yes, so let's begin with the questions. Do it fast, but before you start doing it, have your pen, have your paper, solve it with me, and we will going to check the answers at the end of the question. So let's begin then. What it said, a wire of resistance R is cut into 4 equal parts and they are bundled together side by side to form a thicker wire. The resistance of the bundle is, so the situation is something like this. Let's say this is the wire and this wire is having a resistance R, and I have divided this wire into 4 segments, first, second, third and fourth. So if I have divided this wires into 4 equal parts, then the resistance of each equal part would be R by 4, R by 4, R by 4, R by 4. Yes. And now this wires are connected to form a thicker wire. To form a thicker wire, you need to connect these wires like this. Something like this. I hope these things are clear to you. This will form a thicker wire for them. That this could be A, this could be B. This all having a same resistance. It is of R by 4. So as I know that this all resistance are connected in parallel, so Rp is equals to R divided by N, and my R was the R by 4, and total 4 resistance were connected in parallel, so that should be is equals to R by 16. I hope these things are clear. Yes. Is it? Is it clear? Great. Let's look at the next question. Do it quickly. 4 wires are there and they are made up of same material. What does it mean? When they say same material, that means their resistivity remains the same. Same material have different lengths and radius. So length and radius is different. The wire having more resistance in the following is, so what I know, I understood that R is equals to rho into L by A, but I have not given the area, but I have given the radius. So what I can write, it's an R is equals to rho into L divided by pi into R square. Rho is constant because they said they are made up from the same material, and pi is always a constant. So what I can have, it's an resistance is directly proportional to the L by R square. Now what you need to do is you need to put a value of L and R square for each case and find out the wire having the more resistance. I hope this is clear. Is it? So can you do this? Can you? That this is 100 centimeter, this is 1 mm, and put up using trial error, and let's just find it out that which resistance or which wire having the more resistance. Can you do this? Great. Do it on your own. It's a try yourself. Please do it. Next, look at this. Four conductors of same resistance connected to form a square. Okay. If the resistance between diagonally opposite corner is 8 and the resistance between any two adjacent corner, now start doing it. What the data says that four conductors are there, something like this, of same resistance. It's an R, R, R and R. If the resistance between diagonally opposite corner, let's suppose this is A, this is B, and this RAB is 8. This, if the resistance between diagonally opposite corner is 8, then the resistance between any two adjacent corners. So what I can have, it's an RAB. If I understand this very clearly, what I can get to know is that my current will start moving from here. It is going. Now a certain current will pass through this and the other certain will pass through this. That means these two resistors are in series, these two are in series, and their equivalent are in parallel. While I calculate R plus R, this is 2R. While I calculate R and R, it's a 2R. So this 2R and this 2R, this 2R and this 2R in parallel combination. And when they are in parallel combinations and their resistance are equal, it's a 2R divided by N. It is a combination of two resistance. It's a 2R by 2, which will be an R. And this RAB has been given as 8. So value of an R, it's an 8 ohm. Is it clear? Is it? Now what the requirement? The requirement is the resistance between any of two adjacent corner. So let's redraw the structure. This is the situation. Let's suppose they want this. It's a P versus P and Q. These are the two adjacent corners. This is R, R, R and R. Now I know that the value of R is 8 ohm. So it is RPQ. This is equals to, look at this. This 3, R, R and R. This will form a 3R. This is going to form an R. And this 2 are in the parallel combination. So what I can have, it's an 1 by Rp is equals to 1 by R plus 1 by 3R. It's a 3R plus R, which is a 4R, divided by 3R square, which will give me, and this has been gone, and Rp should be is equals to 3R by 4, which is 3 by 4 multiplied by 8. It's a 4 2 is 8, and this is equals to 6 ohm. I hope you got this. Did you? Did you get the same answer? Are you sure? Well done. Let's have a look to the next question. A wire of 12 ohm is bent in the form of a circle. The effective resistance between the ends of any diameter. Okay, so let's have one circle, please. This is the circle, and the R total is of 12 ohm. Now I need to find out the resistance across any two diametrically opposite position. The total the total circle is of 12 ohm, so this should be of 6 ohm, even this should be of 6 ohm, and as I see that this two are in parallel combination, this 6 and this 6 are in parallel combination. If they are in parallel combination, what I can have, it's in 1 by Rp is equals to 1 by R1 plus 1 by R2. This is equals to R2 plus R1 divided by R1 into RT. This is equals to 1 by Rp, and this Rp can be written as R1 R2 divided by R1 plus R2. Please remember this. This will help us. This is very, very important. When two resistors are there and they are connected in parallel, what I can write, it's an multiplication of two resistance divided by addition of these two resistors. This will help. This will calculate much faster. So what I can write, it's an Rp is equals to 6 into 6 divided by 6 plus 6. It's 36 divided by 12, which will give me an 3 ohm. Even I can do this. Rp, it's a 6 divided by 2. How does it arise? It's an R by N, and this will give me an 3 ohm. So please remember this short tricks. This will help us. Now, shall I add something to this question? Shall I? Let's have a look. Suppose in the previous question, find out RPQ, and the RPQ is this is P and this is Q. So it is one of the quadrant, and you need to find out this RPQ. How could you do this? So what I need to do is that let's divide this into 4 quadrants, and the total resistance is of 3 ohm. So this is of 3 ohm, this is of 3 ohm, this is of 3 ohm, and this is of 3 ohm. All the resistance will be of 3 ohm, and I need to calculate this RPQ. So the situation would something like this. Yes, and a certain current is passing through this, and some other current is passing through this. So this resistance, what I can say, it's a 3 plus 3 plus 3, that is in totality it is of 9 ohm, and this resistance, it is of 3 ohm. These two are in parallel with each other, and when these two are in parallel with each other, then R equivalent should be equals to 9 into 3 divided by 9 plus 3. This is 27 by 12 ohm. This is the R equivalent. Is it clear? Is it? Are you sure? Have you done this? Yes? Ready for the next question? Let's have a look. A technician has only two resistance coils. By using them singly, in series or in parallel, he is able to obtain the resistance that is of 1.5, 2, 6 and 8 ohms. The resistance of these two coils are, okay, how can you do this? How can you do this? So what I can suppose to feel is that maximum resistance is of 8 ohm. So let's suppose one of the resistance is R1, another is R2, and if he has put them into a series combination, then 8 ohm can be produced. It's an R1 plus R2 would be equals to 8 ohm. nth. This is the maximum one, and the minimum one, its minimum is 1.5 ohm. So if I go for the minimum one, it's an R1 R2 divide by R1 plus R2, that would be equals to 1.5 ohm. So what I supposed to do is this: the two resistors are connected in parallel, and when they are connected in parallel, they are the R1 R2 divided by R1 plus R2, that can be written as 1.5 ohm. And when these two are connected in series, it's an R1 plus R2, it's equals to 8 ohm. So what I need to do is, by trial and error, I can check that which of the options will suit me. It's a, let's suppose if it is a 3 and 5. If it is a 3 and 5, this is 3 into 5, 15, divide by 15 by 8. But 15 by 8 cannot produce 1.5. So forget it. 2 into 6. I hope you understand what I am doing. It's an R1 R2 divided by R1 plus R2. It's a 2 into 6. It's a 12 divided by 8. 12 divided by 8, which is a 6 divided by 4. 6 by 4 can produce 1.5, as well as 2 plus 6 can form 8 ohm. Yes, this is the correct answer. You did it. Is it clear? Yes, is it? Great. Let's have the next question. The equivalent resistance of two resistors in series is in 5 ohm and 1.2 ohm in parallel. The higher resistance is, yes, this is the given, R1 plus R2. When they are connected in series, it's a 5 ohm, and when these two are connected in parallel, this is not in 1.2, it's in 12 ohm. So please make it correct and try to solve this. It's a 12 ohm. So R1 R2 divided by R1 plus R2 is equals to 12. Yes, what you need to do is you need to find out the value of R1 and R2, and then at the end you need to calculate the value. You need to find out the value which is having an higher resistance. I hope you can do this. Yes, so this is try yourself. Please do it. For your reference purpose, I already take the answer so that you can come to know that your solution is correct or not. Yes, can you do this? Great. Let's move to the next question. What this is? This is that resistance of a wire is 2 ohm, and it is drawn in such a way that it experiences a longitudinal strain of 200%. Its new resistance will be, the situation is something like this. This is the resistance, and it has been stretched so that its length increases by 200%. It said it experiences a longitudinal strain. It's a longitudinal strain of 200%. That means this is the L, and this should be the 3L. So when this situation arises, we know from the previous class that my volume of the resistance remains the same. As length increases, its cross-sectional area must be decreases. Yes, this is the situation when volume remains the constant. This is the situation. Its volume remains the constant. And if volume remains the constant, what I can have, it's an R directly proportional to the L square. Yes, so let's write it down. It's an R2 by R1 is equals to L2 square divided by L1 square. So this is R2 divided by 2 ohm should be equals to, this is 3L whole square divided by L whole square. This is 9L square divided by L square. This has gone, and R2, that is equals to 9 2s are, it's an 18 ohm. Is it clear? Is it? So can you do this? Can you? Great. Let's have a look at the next question. What this is, it's an equivalent resistance between A and B if each resistance is equals to 20 ohms. So this all are of 20 ohms. 20, 20, 20, 20, 20, something like this. Yes. And we need to find out the equivalent resistance between A and B. So what I can understand is that this two, this and this, they are connected in parallel, and if they are connected in parallel, let's assume the value is R and R. This R and R will be R divided by N. It's a R divided by 2. So this is R by 2. This resistance is R. This is R and this is R. Now, as you can observe that, this and this are connected in series. So their value is R plus R by 2, which should be 3R by 2. And this is connected in parallel with it. It's a 3R by 2 and R by 2. So let's solve this first. It's a combination of 3R by 2 and R by 2. It's a 3R by 2 multiplied by R by 2 divide by 3R by 2 divide by, it's a 3R by 2 plus R by 2. So this is 3R square divide by 4 divide by 3R plus R. It's a 4R by 2. It's a 2R. So this is basically 3R square by 8R. This has gone. So this is 3R by 8. And this 3R by 8 has been connected with the series resistance. It's an R. So my R equivalent should be, this is A and this is B. This is R and this is 3R by 8. So this RAB should be equals to R plus 3R by 8. So this can be written as 8R by 8 plus 3R by 8, which should be an 11R by 8. Now replace the value. It's a 20 divided by 8 and find out the equivalent resistance. Is it clear? Is it? So can you do this kind of questions? Can you? Is it possible for you guys to do this? Are you sure? Can we do this? Can we? Great. Let's have a look to the next question. Let's suppose if each conductor has 9 ohm resistance and the resistance between points D and D, here it is, here this is D, this is E, and each of the conductor has a 9 ohm of resistance. So let's say this is R, 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 and I'm going to put up the value at the end. So what I can see is that this and these two resistors are in series. So R plus R, it's a 2R, which is in parallel with this. So it is R. So this is 2R and R. This 2 are in parallel combination. So first let's find it out. Equivalent of this 2. So it's an R equivalent, which is 2R multiplied by R divided by 3R. It's a 2R square by 3R, which should be 2R by 3. Yes, it is a 2R by 3. Now our resistance are equivalent of this. That means a 2R by 3. And this resistance R, this 2R in, this 3R in series. So what I can get, it's an R equivalent is equals to R plus 2R by 3 plus R, something like this. It's a 2R plus 2R by 3. So this is 2R into 3. It's a 6R plus 2R. It's an 8R by 3. And value of an R, it's a 9 ohm resistance. It's a 8 by 3 multiplied by 9. 3 3s are. It's a 8 3s are 24 ohm. That's it. You did it. Great job. Is it clear? Is it? Well done. Ready for the next question? Are you ready? Let's have a look. The effective resistance between A and B in the given circuit. You need to calculate the effective resistance. First, observe this diagram very carefully and think what we should do and from where we should start. We have done this kind of questions in capacitors as well. So please think, you must do this. Take your time of 10 seconds more and think that how should I do this? How should I do this? Go for it. Can you do this? Can you? No? Let me help you. When this kind of network is there, when this kind of network is there, you need to start your network solving from the other end. That means it's an A and B over here. So their other end would be this, yes, and start solving it from there. It's a 2 ohm, it's a 2 ohm, it's a 2 ohm, this is 6 ohm. So this 6 ohm, this 6 ohm is in parallel with this 3 ohm. I hope you understand this. So if I solve this 6 ohm and 3 ohm, if I solve this, it's a 6 ohm and 3 ohm. What I can have is that RP1, I'm writing it. I'm writing it as an RP1. It's a 3 into 6 divided by 3 plus 6. It's a 3 6 are 18 divided by 9. It's 18 divided by 9. Again 2 ohm. So, so this 2 has been replaced here with with 2 ohm again. So this is 2 ohm, this is 2 ohm, this is 2 ohm, this is again 6 ohm here, which is in equivalent or which is in parallel with the 3 ohm. So this 2 are in again parallel. If I calculate again, it's a 3 into 6 divided by 3 plus 6. Again it's a 2 ohm. So this is 2 ohm, this is 2 ohm, this is 2 ohm, this is 2 ohm. If I calculate it, it's an RAB, which is 2 plus 2 plus 2, which should be in 6 ohm. That's it. The things has been done and answer has been there. Is it clear? Is it so? Is it possible to solve this? Ready for the next question? Are you ready? Let's have a look. What this is, this is they find out the effective resistance between point A and B in the given circuit. Okay, so when I consider that effective resistance between these 2 points, what I need to do, I need to connect a battery over here and try to solve this. But if I look at this very carefully, answer me that does any current passes through this? Let's suppose I write it as an I1 or I write it this as an I2. Does any of the current will pass through it? Now the question is, how could I come to know that whether any current will pass through it or not? Look at this very carefully. These two are the open ends. Even this is open ends. This is end is open. Yes, these two are the open ends. And when it is the case of an open ends, current only passes through a closed path because it requires a closed path to move on. Here it's an open end, so no current is passing through this. And if no current is passing through this, this resistance is of none of the use. This resistance is of none of the use. So I am having a circuit only up to this. And this 2 ohm and this 2 ohm is of waste. So now how can you do this? Look at this, it's a 2, 2, 2, which is 6 ohm. And this 6 ohm is in parallel combination with the 3 ohm. I know that their parallel combination will be again 2 ohm. It's a 3 6 18 divided by 3 plus 6 9. Yes, it's an 18 by 9. We did it in previous slide only. Now it's a 2 2 2, and when it's a 2 2 2, it's an RAB that would be equals to 6 ohm. Is it clear? Is it? So can you do this? Is it possible for you guys to do this? Are you sure? Are you? So look to the next question. The situation is something like this. It's an RAB and you need to calculate this. It's an RAB. So what we need to do is that when and when we could not see that which of the resistors are connected in series and which one of them are in parallel, what I need to do, I need to just simply give them a name. How to give them a name? That we know from the capacitor times. It's a no resistor is there, so I can give the same name. It's an A. It's an A, again moving on this path, and no any resistance, so I should give it name as an A only. It's a B and no other resistance. It's an B. It's an A, one more resistance, let's suppose write it as a C. Now just I'm going to redraw the circuit in a generalized method, that this is from A, this is from C. Let's suppose this end is A, this end is C. From A to C I need to keep one resistance, it is of 3 ohm, it is there. From again A to C I need to keep one more resistance, it's a 6 ohm, it is here. Yes, so all those resistance which have been drawn can be cancelled out. And from C to B, let's say this is B, it's an 8 ohm, it is here. And from A to B, if you move through this path, it is a 30 ohm resistance, it is there. So this is what all you need. Now you understand that this 3 and this 6 are in the parallel combination, so this will form a 3 into 6, 18 divided by 3 plus 6, it's a 9, 18 by 9, it's a 2 ohm. So the situation is, this is A, this was the 2 ohm, this was the 8 ohm, and this combination is of 30 ohm. This is A, this is B. So this is 2, this is 8. So this will be, it's a 10 ohm, divide by 30 ohm. It's an A, this is B. So 10 into 30. So it's an RAB which can be written, or which should be written as a 10 multiplied by 30 divided by 10 plus 30, it's a 40. So this is 10 4s are 40, and 30 by 4, it's a 7.5 ohm. This is RAB. I hope these things are clear. Is it clear? Is it? So can you do this kind of questions? Yes. Let's wind it up, this session over here only. So in this session we were discussing the series and parallel combination, but this is not the end of the series and parallel combination. There are many more questions that we are going to look forward in the next session. So before you start the next session, please revise this session very carefully. Yes, practice as many questions as possible so we can do the more questions and better questions and difficult one in the next session. Till then, thank you, have a good day, take care, bye bye.